Hi grade 11s and welcome to this video. In this video we will be working on KZN's grade 11 mathematics September test for 2025. This test is worth 75 marks and the time allocated is 1.5 hours. Looking at the instructions, we will be rounding off to 2 decimal places unless stated otherwise. And of course remember that the diagrams are not necessarily drawn to scale. Okay, so with that being said, let's get into this video. Question 1.1 says, a school bought a brand new data projector for 20,000 Rand. Okay. And then they tell us the value of the machine depreciated annually at the rate of 13% per annum on a reducing balance. Okay, so it depreciated. So we can see that we are working with depreciation, but notice that if they ever say on a reducing balance means this is going to be compound depreciation. So we can just say it's compound decay. Okay, so we can see that a machine is bought for 20k, it depreciates, and so the question 1.1.1 says calculate the book value of the data projector 7 years after it was bought. Okay, so the book value. Book value just means the final amount. Another word for this is scrap value. So we know that we are starting off with 20,000. Okay, so this is where we start. And we end off with this amount and it's for 13%. And the question is calculate the final amount, okay, if it depreciates for 7 years or after 7 years. Okay, so we need our formula and that is compound decay is A equals P multiplied by 1 minus I raised to the power of n. Okay, P is the principal amount, the amount that you start off with. So we're saying this is the amount that will depreciate, and that is 20,000. So 20,000, and then 1 minus our interest is 13%, which is 13 over 100 as a decimal, that is 0.13. And then this depreciates for 7 years. And this will give us the value of A. Okay, so just punch this into your calculator and let's get the value of A. Okay, so the projector in 7 years' time will cost 7,545 Rand. And then let's just see. So looking at the third decimal, 5, it's going to help the 9 round up. And so that's going to become 10. Okay, so there we go. It is 7,545 Rand. 10 cents. And that is our answer. Moving on to the next question. Question 1.1.2 says, the exchange rate between America, so the American dollar, and the South African rand was a dollar was equal to 18 Rand 45 cents. Calculate the book value of the data projector 7 years after it was bought in American dollars. Okay, so you see that they've given us the exchange rate and we're just calculating this book value amounts that we already have. So from the previous question, we're trying to find out how much is this in dollars. Okay, so if a dollar is 18 Rand 45 cents, then you see that from dollars to rands, we would multiply. For example, if you're trying to find out how much $2 is worth, then this is twice of this. Okay, so that will be about 36 Rand 90 cents. Okay, so that means that if you are moving from rands to dollars, you are going to divide and not multiply. Okay, from dollars to rand, we multiply. From rands to dollars, we divide. Okay, if you had 36 Rand 90 cents and you wanted to find out how much dollars is this, you would simply divide by that exchange rate amount. Okay, and then you would see that you would get 2, so it's $2. So we're going to take that 7,000 that we had and we'll divide by our exchange rate. Okay, so the 7,000 and then let's go ahead and divide. So we'll say divided by 18 Rand 45 cents and let's get our answer. And our answer in American dollars is 408. And then you see that the 8 is going to round that 4 up to a 5. Okay, and 95 cents. And that is our answer. Moving on to the next question. Question 1.2 says, an investment earns interest at a rate of 9% per annum compounded quarterly. Calculate the effective interest rate of this investment. Okay, so we're working with nominal and effective interest rate. You just need to remember your formula here. So here is our formula. 1 plus I effective is equal to 1 plus I nominal over n, all raised to the power of n. So the nominal interest rate is what the bank quotes you. This will usually be compounded quarterly, monthly, semi-annually, okay? And then the effective interest rate is the actual interest that is gained on this investment at the end of the year. Now, what you will notice is that the effective interest rate would be higher than the quarterly interest rate. And this is because interest gains on interest, okay? So this is compounded quarterly, meaning in a full year, it's going to earn interest 4 times. But because interest gains on interest, so whatever your investment was, let's say it was like 500 Rand, this is going to gain interest. Then the next quarter, it will be 500 plus whatever that interest it gains. And then the next quarter, this entire amount, 500 plus the interest that was gained, is going to gain interest, okay? And so it gains even more interest. And that's the reason why at the end of the year, that interest rate is actually higher. So if you look at it as an effective interest rate, it would be higher than the nominal. Okay, so we know that the one that is quoted is the nominal. It's usually compounded quarterly or monthly, semi-annually, and so on. So that's what we're going to put here. So we're trying to find the effective. They've given us the nominal. So this is 1 plus I effective equals, and we have 1 plus I nominal, and that is 9%. So 0. This is as 9 over 100, but just written as a decimal, 0.09, okay, all over, it's compounded quarterly, so divided by 4, and then raised to the power of 4. And then this is, we're going to just transpose the 1 to find I effective. Okay, so rewrite everything that you have here, and just take that 1 over, so it becomes a minus 1. And let's go ahead and punch this into our calculator and see our answer. So our answer as a decimal is first 0.09308, but then you need to ensure that you write this as a rate. Okay, they want the effective interest rate, so it needs to be expressed as a percentage. So multiply it by 100. So on your calculator, just say times 100, and there we go. We have our effective interest rate is finally 9 points, and you see that 8 is going to round the 0 up to a 1, so we have 9.31%, and that is the effective interest rate. Moving on to the next question. Question 1.3 says, the value of a flat increases annually at a rate of 12% per annum on a straight line basis. Okay, so annually, it's also just straight line. Calculate the current price of the flat if it will be valued at 500,050 Rand in 60 months' time. Okay, so we know that it is going to increase on a straight line basis, meaning we are using simple interest growth. And the formula looks like this: A equals P multiplied by 1 plus I multiplied by N. Okay, so now we can see that they're telling us that the flat is going to increase annually. And we have to find the current price. Okay, so the starting amount. Okay, so of that flat, if it will be valued at this amount in 60 months' time. So they've given us the value of A. So the only calculation that you have to actually remember here is the 60 months. We know that this is appreciating on a straight line basis, meaning this should be in years. Okay, it's going to increase annually. So 60 months, how many years is 60 months? 60 months equals, just say 60 divided by 12, okay? So you just want to find out how many years are there in 60 months, since there are 12 months in a year, okay? So that would be 5 years, and that's really all the major calculation we need to do. Then we just find this. Okay, so they've given us the value of A, which is 500,050 is equal to, and we have P, and then 1 plus, and our interest is 12%, so that is 0.12. Straight line, okay, not compounded, and then multiply by 5 years. And all we have to do is make P the subject of this formula. You see that to do that, P is multiplying to all of this. So if you could just get rid of this, then you'd find p. Since it's multiplying, the only way to get rid of it is to divide. So we'll divide both hand sides by everything there. Okay, so we have 1 plus 0.12 times 5, and then same thing on this side. And so really what we're working with is these cancel, and we're just trying to find the value of p, which is equal to, and it's all of this. Okay, so now we can punch that into the calculator and get the final value of p. And that principal amount, okay, the current value of that flat is 312,531 Rand 25 cents. And that is our answer. Moving on to the next question. Question 1.4 says, 3 years ago, the selling price of a dozen of eggs was 16 Rand 25 cents. The selling price of a dozen of eggs is currently 18 Rand. Calculate the average yearly inflation rate at which the price of eggs increased over the 3 years. Okay, so whenever you hear inflation, just remember that you are actually working with, first of all, growth, because inflation makes prices go up, and it's specifically compound interest growth. Okay, so remember, inflation makes prices go up. But the thing about it is, it doesn't increase, steadily. It doesn't just increase as in, we're just going to add 2 Rand to the price of eggs every year. That's not how it works, okay? It increases by a rate. Okay, so for example, if it's going to increase by 15%, for example, if bread costs 20 Rand today, okay, then it's going to increase by 15%, which is about 23 Rand. Then the next year, they're not just going to say, okay, we can see that it increased by 3 Rand, so we're just going to add another 3 Rand. No, this entire amount is going to increase by 15% again. Okay, so that 23 Rand, and then you can just say 1.15, and that would increase it by 15%. Okay, because it's multiplying to the 1 and the 0.15. Okay, so instead of it being like adding 3 Rand, you're not doing that. Okay, you're increasing it like this, and then that is 26 Rand. I'm just calculating it here. 45. Okay, 26 Rand 45 cents. That's how much it's going to increase by. So you see that 45 cents may look not so meaningful, but it will be once it starts getting much bigger. Okay, so remember that inflation, you're just going to always use compound interest growth. Okay, so our formula for compound interest is A equals P, 1 plus I raised to the power of N. Okay, so let's just speak about what these values are. They say 3 years ago. Okay, so from now, 3 years ago, that the selling price of a dozen of eggs was this. Okay, it used to be 16 Rand 25 cents. And then now the selling price is 18 Rand. So you can see that it grew from this amount to 18, meaning this is the amount we started off with, P, our principal amount, and then this is the amount it ended off with, it accumulated to, which is 18 Rand. Okay, so we know what A and P are. We're just going to say this is 18 is equal to 16.25, and then 1 plus, and you can clearly see they're asking us for that yearly inflation rate. Okay, so it's not compounded monthly or anything like that. It's a yearly rate. So say plus I, and then raised to the power of, they said 3 years ago. So to the power of 3. And what we are trying to find is the value of I. Okay, so what is stopping us from getting to the I? It's not really this 3. Yes, this 3 is also a problem, but the first problem would be the 16. So we need to get rid of it. And because it's multiplying to this, we can get rid of the 16 by dividing by 16.25. Okay, and we divide both hand sides because what you do on one side, you must do on the other side. So I'm going to hold on to this like this. I don't want to work with decimals. So we have 18 over 16.25 is equal to, these cancel, and you're left with 1 plus I raised to the power of 3. Okay, now what is the next thing stopping you from getting to that I? Now it's the 3, okay? So that's the next thing that is in the way. So we can get rid of raised to the power of 3 or power of 3 by using the inverse of this, which is to cube root. Okay, so we would cube root this, and then that would get rid of that. But you also have to cube root this side because it is an equation. Okay, so we currently just have, I'll just write this on the side. We have 1 plus I is equal to, and rewrite all of this. And then what else is stopping you from getting to this I? It would now be the 1. So transpose the 1. And now all we have to calculate is all of this, the cube root of 18 over that. And then just take that 1 over, so minus 1. So punch this into your calculator and we'll get our answer as a decimal first. Okay, so I is equal to 0.034680, not rounding off yet. And then remember, they do want to know the inflation rate. So express it as a percentage, as a rate. So multiply by 100. And finally, I is equal to, so on your calculator, just say times 100. It will say ounce times 100. And then we have 3.4, and that 8 is going to round the 6 up to a 7. So 3.47%. That is the inflation rate. And that is it for that question. Moving on to the next question. Question 1.5 says, Mr. Mavundla invests 12,000 Rand in an account that earns interest at a rate of 11.35%. Okay, so invest, meaning this money is going to grow. Okay, so we know that we are using some sort of growth. You can already see compounding. So compound interest growth, 11.35% per annum. And then they say he had forgotten what the compounding period of the investment was. Okay, so he doesn't know the compounding period. He doesn't know whether it was compounded monthly or quarterly or semi-annually. Okay, so we'll hold on to that. So they say after 20 unequal amounts of interests were added to the original investment. Now, I'm actually going to point something out with this. You see, grade 11s, if they decided not to tell you that it was compound interest, okay, it was going to be difficult for them to not say it because they needed to tell you compounding periods, okay? If not, you wouldn't know what was missing. Okay, so they had to say this. But this alone is actually telling you that this was compound interest. These are unequal amounts of interest that were added. The only way that an equal amount of interest keeps being added to an investment is through compound interest growth. Okay, with simple interest, it's straight line. So meaning the same amount of interest will keep getting added each year. But with compound, interest gains on interest. So that way the interest is different every year that gets added to the amount. Or every month, okay, depending on the compounding period. And then they say the accumulated amount was, okay, so they're telling us the value of A. That was about 36,000. And then how many years did it take for the original investment to accumulate to this same amount? So they're still asking at how many years, but they also just didn't tell us the compounding period. Okay, but that's not really a problem because let's just look at the formula we're going to use, right? It's compound interest growth, meaning A equals P and then 1 plus I raised to the power of N. Okay. You see, when we look at N, if you're just looking at N like this, you could look at it as the total amount of compoundings. For example, if I said this was compounded monthly, and let's say it was invested for 3 years, right? You wouldn't just say to the power of 3. You'd say to the power of 3 times 12 so that it can earn interest every month for a total of 36 months. So do you see how this also tells you the amount of interest that was earned? Since we know that it's going to earn interest for 36 months, for example, okay, if it earns interest for 36 months, that means that there were 36 sets of interest that was added to the money. Okay, so let's go ahead and just, speak about the amounts that we have here. So they told us the interest, so we know what I is. They told us it's 20 unequal amounts. So this is going to be the amounts that we're going to put by N. And the reason why is because, as you can see, they say after 20 unequal amounts of interest. Okay, so that over there tells you how much interest was added because that money is going to gain interest for the amount that is going to be there. Okay, if it's 36, it's going to gain interest 36 times. So that is 36 sets of interest being added again. So we know this is N. And then they also say that this is the amount it accumulates to. Okay, I'll just highlight it from here. So it accumulates to this. So we know this is the value of A. Okay, and the initial amount invested was 12,000 Rand. So this is what was put in. Okay, so we can just fill everything in. We know that the only thing missing is that compounding period. Okay, so A is 36 and we have 193.15 is equal to, the principal amount is 12,000, 1 plus, and then I. Now you see how you usually write this because you know it's compounded, okay? It has a compounding period. It's not just gaining interest every year and then done. It's gaining interest every year compounded somehow, okay? So what we're going to do here is the same way we usually put the interest, we'll say 0.1135, and then you say over the compounding period. That's what we're going to put here. So that's what's missing. I can't really call it N, I'll just call it X, okay? Or M. The reason I'm thinking of calling it M is because you know how like with when you're changing interest rates, okay, not effective and nominal, but like when you're converting one compounding to another, that, and they usually call that M. So I'll call it M, raised to the power of, but you could call it anything. X is even fine. And so then we're saying raised to the power of 20, okay? So because we know it's going to gain interest 20 times, 20 sets of interest. Okay, so this is what we have. It's a new one. I haven't really seen a question like this before, but you should see that in your entire formula, they can ask you for anything. They can ask you for A, P, I, okay, and now we can see they can also ask us for the compounding. So let's go ahead and find this. First problem, 12,000. So divide both hand sides of this equation by 12,000. When that is gone, we have 1 plus 0.1135 over m raised to the power of 20, and we're going to rewrite this. Okay, next problem that we have here would be the 20. So we need to get rid of that, and we can find the 20th root of both hand sides of this equation. Okay, so that breaks open and we're just left with, I'll just write it on this side, 1 plus 0.1135 over m, and now we have all of this here. Okay, and now we can take that one over. So it is 0.1135 over m is equal to, and then rewrite this, and we're just taking that one over. So it was positive 1, it's going to become a negative 1. Okay, and now do you see that, yeah, it's going to be a number, but I just want to get this alone. So look at how we're going to do it. I'm not just going to like show all of those steps. But if this is a number alone, and we have this over here, which is a fraction, you can kind of put this over 1, and we're going to cross multiply. So if we multiply it across like this, what we will get here is 0.1135, okay, multiplied by 1, which stays the same. And then over here, you're saying m times this numerator. Okay, so it will just be m, and then all of this, I'll put it in a bracket. Okay, yeah, I said I'm not going to write everything, but then, yeah, I still did. And now finally, to get m alone, you see that all you have to do is divide both hand sides by this number. And that's what we're going to do. Divide both hand sides by this number. So m is equal to all of this. So 0.1135 divided by all of that. Okay, so this is what we get when we do that. So finally, we know that m is equal to the compounding. You see that that's just 1.999. This is just 2. Okay, so we can just say m is equal to 2. So now you still need to answer them because the question is specifically how many years did it take for that investment, okay, to accumulate to this. So we know the compounding is 2 now, meaning this was 0.1135 over 2. When we say over 2, what kind of compounding is that? So if you said over 4, that would be quarterly. If you said over 12, that would be monthly. Over 2 means it gained interest twice in a year, meaning that is semi-annually or half-yearly. Okay, so we know it's half-yearly, and so if it was compounded half-yearly, then we knew that this was 20. So how many years was it compounded for? This part, we usually say whatever n is, multiplied by the compounding, but we know that is 2 now. So if this n times 2 is equal to 20, then n is actually equal to 10. Okay, so there we go. That's how we'll find that. So you just have to think it through. Okay, so I'll just write it in full. It was invested for 10 years, compounded semi-annually. Okay, so that amounts that 12,000 was invested for 10 years at 11.35% per annum, compounded semi-annually, or you could also say half-yearly. And that is our answer. And that is it for question 1. Question 2 says 2.1, it is given that for events A and B, the probability of not B is equal to 0.67 and the probability of A or B is equal to 0.57. So 2.1.1 wants us to calculate the probability of B. Okay, let's try to understand the info they've given us. They've given us the probability of not B. Okay, so regardless of whether these are, mutually exclusive or not, so I'll just put two diagrams. So this one would intersect like that. So regardless of whether they were mutually exclusive or not, let's understand what the probability of not B would mean. Okay, so probability of not B just means exclude B. So we can highlight everything else except for B. So that will be everything else, even outside the circles, but just don't include the circle of B. And so this is what this would look like here. So you can see that. Likewise here, we're just going to exclude B, so circle everything else but B. So something like that. Regardless of what it looks like, do you see that you're taking everything else? In the Venn diagram, if you add up all the numbers that we get the whole of our sample. So that means the probability of not B is everything else, okay, that is circled excluding B. So minus the probability of B. Okay, in both cases, everything else minus the circle of B. So that would be the probability of not B. So you can see that the first information is useful to find this. Okay, because there you see probability of B, so we'll just substitute the value in there. Okay, so let's go ahead and do that. Let me just leave those diagrams there. Maybe they'll be helpful. And so we have 0.67. That is the probability of not B. We'll just say 0.67 equals, and we have 1 minus the probability of B. And you see that to solve for probability of B, it's currently negative because it has a negative in front of it. You can just take it over to bring it here and make it positive. So now it's positive. And you still have this 1 here on the right-hand side and transpose the 0.67, but it becomes negative. So that's how we will find the probability of B. Okay, so that should be 0.33. Okay, because 33 plus 67 is 100. So that is our answer. Moving on to the next question. Question 2.1.2 says, calculate the probability of A if it is given that events A and B are mutually exclusive. Okay, so now we can actually choose a diagram. Okay, they're mutually exclusive. You can see it as they have mutually decided to exclude each other. So that is what it looks like. And now how do we use that to find the probability of A? Okay, we can use the second piece of information because there's a calculation for the probability of A or B since they gave us that. Okay, so how we find the probability of A or B is like this. You see, we're going to take either A or you can take B, meaning you're going to circle A and you're also going to circle B. It doesn't include anything outside the circles. So to find this, we know that the probability of A or B is 0.57. And so we're saying probability of A or B is found by saying probability of A plus the probability of B. There's no intersection in this case because they're mutually exclusive. And then 0.57 is equal to the probability of A plus the probability of B, which we have. Now we can actually use this because do you see that regardless of what this was, okay, probability of not B would be calculated the same way in the case of mutually exclusive and if they were not mutually exclusive. Okay, so we're just going to say that is 0.33 and now we can finally find the probability of A. So probability of A is equal to, and we're just going to transpose that. So that's 0.57 minus 0.33. Finally, probability of A equals, that's 24. Okay, 0.24. And that is our answer. Moving on to the next question. Question 2.2 says, a survey was conducted among 140 workers, okay, about the category of salary they earned and the environment under which they worked. The results are summarized in the table below. Okay, so we have the category of salary, so people who earned from 5,000 to 25,000, okay, and so on. and then good environment, moderate environment, and bad environment, and they also give us the total. So this is a contingency table, and just remember how they work. We add going down like that. This would be the total people who work in a good environment. Okay, we add like that and like that, and then we also add sideways. Okay, so like that, these would be the total people who earn from 5,000 to 25,000, and all through as well. And then we can also add the totals like that as well. Okay, and like that. So we do end up with 140. And they say 2.2.1, write down the values of M and P. Okay, so let's find M and P. So M is over here. You can see that there are two ways to find it. You can find it by saying all of this plus M gives us 49. Or you could find it by saying M plus these, okay, give us 25 because we totaled that way. So any way would be fine. I'm just going to go ahead and say, we're going to say 23 plus 22 is 45 plus M equals 49. And so M equals 49 minus 45, which is just equal to 4. So M is equal to 4. And let's find P. How can we add P? We can add like this and say it's equal to that. We could also add like this and say it's equal to that. Okay, so we'll just add. Let's just add this way. Okay, so I'll just say 22 plus 3 is 25 plus P equals 60. And so P is actually equal to 60 minus 25. So finally, P is equal to 35. And there we go. Okay, so those are the two values that we have. M equals 4, P equals 35. Moving on to the next question. Question 2.2.2 says, calculate the probability of randomly selecting a worker from this group who worked in a good environment and whose salary was in, okay, the range of 25,000 to 40,000 category. Okay, good environment, 25K to 40K. So we're looking for good environment and then 25 to 40. So you can see that that is 22. So as a probability, it is 22 people out of the total 140 people we have in this study. Okay, so we'll just say 22 over 140, and then this simplifies. Okay, I think they're both divisible by 2. So that's going to be 11 over 70. And that is our answer. Moving on to the next question. Question 2.2.3 says, are the events working in a moderate environment and earning a salary above 40,000 independent? Justify your answer with relevant calculations. Okay, so with independent events, to know whether events are independent or not, then the probability of one event and the other, okay, should be equal to the probability of that first event multiplied by the probability of the second. And if you see that these are exactly the same, you can look at them as decimals, then it would mean that they are independent. And remember, with independent events, it just means that the outcome of one event is not influenced by the other event. Okay, so the two events we're working with is a moderate environment. Okay, so we're just going to check if probability of, I'll just call it moderate, okay, and above 40,000, so greater than 40,000, and we're going to find out what that is first. So we're looking for moderate environment and greater than 40,000. Okay, greater than 40,000 is here. Okay, everything greater than 40,000. So because these are values that are greater than 40K, but less than or equal to 65K. So we're looking for greater than 40K and a moderate environment. So you can see that that is 12. So we'll say 12 out of the total, which is 140. So 12 over 140. And then we're going to go ahead and look for the probability of A and the probability of B. So that's the probability of a moderate environment. Okay, randomly picking somebody who works in a moderate environment, and then we'll find the probability of earning greater than 40,000. Okay, randomly picking someone who earns more than 40,000. Okay, so let's go ahead and see this. So probability of finding someone who works in a moderate environment. So that the total for this is 30, because we're just trying to find or randomly pick somebody, okay, out of these workers who works in a moderate environment, regardless of what they earn. So that is 30 over 140. So we'll just say this one is 30 over 140, and then people who earn more than 40,000. So people who earn more than 40,000 regardless of the environment, that would be 25. So that is 25 over 140. So 25 over 140. And now we need to multiply to see whether it actually gives us this. So we'll say probability of moderate and then multiplied by the probability of earning more than 40,000. We could have just said 40K, but it's fine. And so this is what is 30 over 140 multiplied by 25 over 140. I should also write this as decimals, and I'll go ahead and do that. Okay, so as decimals, that is 0.03826, okay? And we can just round off the two decimal places because we're looking at it as a probability. You could do that, or you just express it as a percentage. So that is equal to 0.04. And then we can also just make sure we compare at the decimal level, really, just to be sure. And let's find out what 12 over 140 is. Okay, so that's, as you can see, completely different. So this is 0.0857. And if we just round off to two decimal places, this is 0.09, okay, because the 5 will round the 8 up to a 9. Okay, so looking at these two numbers, this is a 9% chance, this is a 4% chance. As you can see, they're completely different. So we can see that the probability of moderate multiplied by the probability, or let me just say it like this, the probability of moderate and greater than 40,000 is not equal to the probability of moderate multiplied by the probability of greater than 40K. Okay, so what this means is if they were independent, they should be equal. But they are clearly not independent, so we can go ahead and tell them that the events are not independent. Okay, so this means that earning an amount greater than 40,000 actually is influenced by the environment that you work in. Okay, and that is our answer there. Moving on to the next question. Question 2.3 says, Mr. van der Merwe rolls an ordinary fair dice in a game. The rules are as follows. So, if number 1 is rolled, then he wins. If number 2 or 3 is rolled, he loses. And then if number 4, 5, or 6 is rolled, then he gets to roll again. Okay? And then I say, if Mr. van der Merwe rolls again and a number from 1 to 4 is rolled, then he loses. And then a number from, okay, so loses, I'll just put that in, purple. And then if he gets a number 5 or 6 is rolled, then he wins. Okay, we're just going to have to put down this. If not, we're just going to get lost or get intimidated by the data. So let's see. You see, it's a dice that is being rolled. We know that a dice has 6 faces, okay, 6 numbers on it, 1 to 6. But look at the categories they've put. So there's no way the tree diagram is clearly a tree diagram, okay, because one thing happens, we're looking at the chance of this happening, that happening, and so on. So when we're putting this tree diagram down, you can't just put down the dice, okay, the outcomes of the dice, because that wouldn't make any sense. Because then you're like, okay, there's 6 sides on a dice, and then you put 6 branches. And what are you going to put here? Okay, this is 1 out of 6. What happens with 1 out of 6? You see how that's confusing? They've given you 3 categories, okay, for the first roll. It's either he wins, loses, or rolls again. So we're going to have 3 branches. Okay, and I mean, they did say something else. Well, they did say something else happens, but this happens if it rolls again. Okay, so we could look at the probability of him winning, losing, and then rolling again. So the chance of him winning is if he ends up with number 1. Well, unfortunately, there's only one face with 1 on the dice, meaning he has a 1 out of 6 chance of winning in this first roll. And then losing. He loses if it lands on 2 or 3. That's 2 numbers, okay? So that means he has a 2 over 6 chance of losing in the first roll. So 2 over 6. And then if he gets 4, 5, or 6, that's 3 numbers. So that's 3 over 6. Then he must roll again. And then they speak about what happens when he rolls again. Okay, so now by rolls again, here we're going to have our branch. Okay, but look at what they say. You see that in here, we only have two categories, okay? It's losing or winning. So at least, they only let you roll again and then, you could either win or lose. So if he gets to roll again, look at what happens. He could either win or he could lose. If he rolls a 1, a number from 1 to 4, which is 1, 2, 3, 4, 4 numbers, then he loses, okay? So he could lose here, and that is a 4/6 chance, okay, here. And then he could win if he gets a 5/6. So that's 2 numbers or 2 faces, which is 2/6. And this is what this looks like. And he wins here. Okay. Then they also say the game stops when Mr. van der Merwe wins or loses. Then the game is over. Okay. 2.3.1 says represent the above information in a tree diagram. Okay. Show the probabilities associated with each branch and the outcomes of this game. So here's our tree diagram, and then let's also just show them the outcomes. So he could win. So these are the outcomes that we're going to get. I'll just say these are our outcomes. So he could just roll and maybe it lands on a 1 and then he wins. Okay, so there, that would be win, and that would be a 1/6 chance. Let's also just try to express this as a percentage. 1/6 is, okay, I'll just say about 17%. I'm just trying to understand it like that. So about 17% chance of winning. And then he could also just maybe roll and then he lands on any of these options, 2 or 3, and then immediately he loses. So he could lose, and that is a 2/6 chance of losing. So double of that. So about 33%. So we're just going to say 2/6. Okay, 33%. So 33% chance of losing. And then the other outcomes. So with rolls again, you see that there are 2 more possibilities here. So this outcome will be seen as he could roll again and either lose, or he could roll again and win. Okay, so let's look at roll again and lose. So roll and lose. And to find that, you're going to say the roll is 3/6 and then lose is 4/6. So you will say 3/6 multiplied by 4/6 to get that outcome. Okay, which is 1/3. So 1/3, and that is a 33% chance. And I'm really just going to use the fractions, but I'm just trying to look at the percentage as well. And then he could roll and win. Okay, and that would be 3/6 times 2/6, and let's get that. Okay, and as you can see, that's 1/6. So 1/6, which is about 17%. Okay, so these are the outcomes, and that's everything they asked for. Okay, so interesting game. In a way, you can think about the way that whoever's organizing this game could probably gain money is to say, okay, the raffle is for maybe 1,000 Rand. You get to walk away with 1,000 Rand, but then you must pay an entry fee of maybe 100 Rand. And then maybe they'll put a condition that to roll again, you must pay 50 Rand or something like that. So because of that kind of situation, they still end up earning a lot of money. And of course, they will have 1,000 Rand in pockets in case somebody wins. Okay, so that is it for that question. Moving on to the next question. And then question 2.3.2 says, write down the probability that Mr. van der Merwe wins on the first roll of the dice. So the probability that he's going to win just first try, that is 1/6. And we have that, okay, the outcomes. So that's 1/6, or you can say roughly 17% chance. So probability that he just wins equals 1/6. Moving on to the next question. And then the last question, 2.3.3 says, calculate the probability that Mr. van der Merwe will lose at this game, and then write your answer as a percentage. So they just want to know the probability that he will lose. Okay, look at how we're going to look at this. Focus on the outcomes. You just want to find the probability that he loses, meaning you just need to look at your outcomes, and wherever you see lose, you're going to take that. So he could either roll and then lose in the first roll, and then that is 2/6. Or, and please take note of the word or, okay? Or he could land on a certain number. So if he lands on 4, 5, or 6, he will get to roll again. So if he gets to roll again and then he loses, then that is a 1/3 chance. Okay, so we could either pick this or this. When you use the word or increases the chance of things happening. Okay, just kind of like a quick example. If you have a bag and you have, let's just put like 5 balls in this bag. Okay, so we have red, blue, and purple. If I say, what is the chance of getting a blue ball? Okay, let's say I said there's a raffle. If you end up with the blue ball, you win. And so that would just be a 2 out of a total of 6. Okay, I just decided to add 6 balls in here. Okay, 2 out of 6 chance. But then I say, if you get a blue or a purple ball, then you win. So it means that you can either get a blue ball or a purple ball. Either way, you win. And that increases your chances now. So it's not just the 2/6 we're looking at. It's 2/6, or you could even get this purple ball, which is 3 out of 6 balls. Okay, so that increases the chance, meaning we're going to add these two together because you can get either one of them and you still win. So your chance of winning is now a 5 out of 6 chance. Okay, so that is what OR does. It will increase the chance, so we know we're going to add here. And so let's go ahead and take these amounts and we're adding it. So I'll just write it out first. We're saying this is the probability of losing or probability of rolling and then losing. Probability of losing straight away was 2/6, and then this one is 1/, I'll just put the full calculation. So this was 2/6, and then we're saying plus, and then rolling and losing, that is 3/6 times 4/6. So 3/6 times 4/6, and then that is just, I can simplify that to 1/3. We know that simplified to 1/3. So this is a 2 out of 3 chance of losing in total. He has about 66.67 chance of losing. Okay, and that is our answer. And there we go. Okay, so that is it for question 2. Question 3 says, the table below shows the number of learners who participated in a maths Olympiad at a school over the past 9 years. Okay, so first year, 5 people, second year, 8 people, and so on. And then 3.1.1 says, calculate the mean of the data. And then you see they also ask for standard deviation. So it's better to use your calculator to find the mean so that you could just use your calculator again to find the standard deviation. Okay, so on your calculator, go to mode and then go to stat. And then you're going to see an option that says 1 VAR. Okay, it's for a single variable data set. And you're going to record these numbers in here. Okay, so once done, just make sure that it is actually 9 numbers that have been recorded. Then you're going to press AC, Shift, and 1. And then go for the option that says VAR. That will be option 4 on your calculator, depending on which one you're using. Okay, and then I have to go here for variable. Then go ahead and look for the mean. So the mean is going to look like this. Okay, line on top, not that. Okay, so the mean is, as we can see, that is just 26.89, which, I mean, these are learners. You might as well just say about 27 or 26, but it's fine to leave it like this. So our answer is 26.89. And then the second question, 3.1.2 says, write down the standard deviation of the data. So I have to remove that, okay? But then you can just go ahead and press AC, Shift, and 1, and you're going to go to that same place, VAR, okay, option number 4. And now you're looking for standard deviation, which is going to look like this. Okay, it's going to say the standard deviation of your X values. And that is this. And our standard deviation is 19 point, and that's going to round up to a 6, so 5, 6. And that is our answer. And moving on to the next question. Question 3.3 says, for how many years was the number of learners who participated in the Maths Olympiad less than, so it is less than 1 standard deviation below the mean? So we would need to find out exactly what 1 standard deviation below the mean looks like, and then we're going to look for the values that are less than this. Okay, so 1 standard deviation below the mean. So if we're at the mean, we go a standard deviation less than the mean, meaning you're just going to say mean minus standard deviation. Okay, so we know that our mean is 26.89, then minus the standard deviation, which is 19.56. And let's get that answer first. So this is one standard deviation below the mean. Okay, and you can still do normal calculations here. So press SD, and we can see this is 7.33. So we are looking for values that are less than 7.33. Okay, values less than this, 5 is less than it. And then, yeah, that's it. There's no other number less than that. So it's only 5, meaning when you're answering them, they say for how many years was the number of learners, okay, who participated less than this. So you're going to say for 1 year, and that is our answer. We'll just tell them it is 1 year, and that's it. Moving on to the next question. Question 3.2 says, the amount of time in minutes that a group of learners waited one afternoon before they were helped by a school librarian was recorded. The information was summarized in the frequency table. Okay, so we've got the time in minutes, so people who waited from 0 to 4 minutes, 4 to 8 minutes, and so on. And then these are the number of learners in each category or each class. Okay, the first question, 3.2.1 says, write down the modal class of the data. So it's the modal class, the mode. The mode is the number that repeats itself the most, okay? But this is a class. So how we see how many times a class repeats itself or shows up is by looking at the number of learners in this category, the frequency. So for example, there were 6 learners who waited from 0 to 4 minutes. Okay, so 0 to 4 minutes, 6 learners. And so there were 12 learners from 4 to 8 minutes. So if the mode is the number that repeats itself the most, then the modal class would be the class with the highest frequency. So the highest number of learners in that category. So we can say that's 20. So that is our modal class. We can just go ahead and tell them this is where the time was greater than 8, but less than or equal to 12 minutes. And that is our answer. Moving on to the next question. Question 3.2.2 says, complete the cumulative frequency column of the table provided in diagram sheet 1. Okay, so just cumulative frequency. Let's go. So the cumulative frequency is just accumulating the frequency. So we're just adding the frequency. Here we have 6, so that's the only number we have. So we'll just leave it as 6. And then 6 plus 12, and that's 18. 18 plus 20, and that's 38. 38 plus 16, so that's 40, and then plus 14, which is 54. So 54, and then 54 plus 6, which is 60. Okay, so 60 learners in total, and that is our cumulative frequency. So I'll just leave that as, that's completed. Moving on to the next question. Then question 3.2.3 says, write down the total number of learners who waited to be helped by the librarian that afternoon. Okay, so the total number of learners. You see, as we were adding these learners, you see, we are saying that all of these people here who waited for these classes, they add up to 18. And then when you say all of these ones, they add up to 38. So everybody would add up to the final amount here you have by the cumulative frequency. So it means that there were a total of 60 learners. So we can just go ahead and tell them there are a total of 60 learners because all of them were waiting to be helped. Okay, moving on to the next question. Question 3.2.4 says, on the grid provided in diagram sheet 1, draw the cumulative frequency graph, which is the ogive of the data. Okay, so we're just going to have to draw this. Remember, it is a cumulative frequency graph, so we are going to use the cumulative frequency column, and we are still using the time. So there's something we need to note here. You see how all of these numbers are going to be paired with a cumulative frequency value? Like 4 is going to go with 6, and 8 is going to go with 18, and 12 with 38, and so on. Then this means that this x value of 0, remember that it's always going to go with a y value of 0. Okay, so it's always going to go with the y value of 0. Just keep that in mind. Okay, let's go ahead and draw our diagram. Well, if you have grid paper, it will make this easier. But I'm just going to go ahead and just draw this down. Okay, so we put down our y-axis, and this is the cumulative frequency. So I'll just write that down. Okay, so I'll just put that over there. I'll turn it like that. And then we have the x-axis. And just make sure to title your x-axis. You can call it time waiting in minutes. And we're just going to go from 4, 8. Okay, it's not a lot of numbers, so it should be fine. Okay, so there we go. And then just make sure to title it. This is our ogive, or you can call it your cumulative frequency graph. Okay, so plotting down, we're just going to go 0 and 0, clearly, and then 4 and 6. So 0 and 0, 4 and 6, so that's just a bit above 5. And just make sure to plot the other ones as accurately as you can. Okay, so roundabout like this, and then you're just going to join it. It's going to be a curve, so it's going to do that and touch all the points and then down like that. Okay, and that is our ogive. Moving on to the next question. Question 3.2.5 says, use your graph to estimate the interquartile range of the data. Okay, so the interquartile range, or the IQR, is found by, it's really the range of your quartiles. So the highest quartile minus the lowest one. So that is Q3 minus Q1. So we need to find Q1 and Q3 to do this. So Q1, if you're looking at your data in 4 quarters, this is marked at 1/4 of your data set. Okay, so 1 out of 4 of these. So we're just separating them into 4 sections. So it is 1 out of 4 of the total. And then Q2 is 2 out of 4, which is exactly a half. And then Q3, that is 3/4. And then this would be 100% of your data. So this is how we're just going to look at it. And we are answering them in terms of time. Okay, so this is just the cumulative frequency. And to find this, to find the position of Q1, what we'll do is simply say, so to find Q1, I'll just say position. So it's not the actual amount yet. We'll say 1/4 and then multiply by the total learners that we have. So if you say 1/4 times 60, it's like saying 60 divided by 4, which is 15. Okay, so it means that Q1 would be marked at the 15th person. So let's go. We'll go from here and go to learner number 15. And once we reach learner number 15, once you hit the ogive, you're going to go down. Okay, so this looks about, I'll say about 7. Okay, so yeah, about 7. Q1 is about 7. So we can finally conclude. We know the value of Q1 is about 7. And then, well, let's just check that. There is a range of answers that they will accept, but I'm just going to see it like this. So from 8, this is actually not a good way because I'm not even using grid paper. So there's no way of really verifying. Okay, so you can just, from here to here, you could cut this into, so from 4, it's 5, 6, 7, 8, exactly 4 numbers. So if we try to divide this into 2 equal parts, that's not really equal. I think I'm just being too careful here. Okay, so 2 equal parts. So in the middle here, we have 4, and then cut this into 2 equal parts. So that would be, I'll just push that a little bit more like that. And so I'll see this as 4, this is 5, this is 6. And then, yeah, so not really 7, 7, kind of like 7 point something. Okay, this looks more fair. So yeah, I'll just take 7. That's fine. We'll just take 7. There will be a range of answers they will accept, so it's fine. Okay, so now to find Q3, right? Q3 would be found by, we're going to go 3/4 of our data set. So this is 3 blocks out of the total 4. So we'll find the position first by saying Q3. To find the position, we just say 3/4 multiplied by 60. Okay, so 3/4 times 60. We can just say half of 60 is 30, and then 30 plus 15 is 45. So that would be 45. And then we will just go to the 45th learner and then check that. Okay, so 45, and then just like that. Just try to make sure it's as straight as possible. On grid paper, it would be so much better. Okay, so I'm going to see that as, it's not really, it doesn't really look like it's 13. It looks like it's 13 point something. So maybe 13.5 roundabout. Okay, so go ahead and say that Q3 is approximately 13.5. And then finally to find that IQR. So we'll say that the IQR, remember, it's the range of your quartiles, Q3 minus Q1, which is finally 13.5 minus 7, and then that just gives us 6.5. Okay, and I'll just go ahead and leave it like that. There is a range of answers that they would accept. Okay, and that is it for question 3. Question 4 says, in the diagram below, the graphs of f of x, which is equal to sine bx plus q, and g of x, which is equal to cos x plus p, are shown for the interval where x is greater than or equal to negative 90 degrees, but less than or equal to 180 degrees. Okay, so we can see where it goes. And the first question says, write down the amplitude of f. Okay, so the amplitude is the height of a trig function from the midline. Okay, so from the middle. But you can spot it by looking at the equation of this function. So you see how it says f of x equals sine bx, okay? Think about the number in front of sine. That is an invisible 1. And so that means that the amplitude is 1. It's always going to be the absolute value of whatever is here. So if it was negative 1, the amplitude would still be 1. Okay, so the absolute value. So it is 1. Moving on to the next question. Question 4.2 says, write down the period of g. So the period of g, okay, to find the period of a trig function, the period is how long that graph takes to complete a cycle. So it's a graph of g, and let's just see what kind of graph this is. Okay, so it is the cos graph. You know that normally a cos graph, okay, what it looks like is like this. It goes from being up here at 1 and then hits 0, negative 1, and then back like this. So this is one cycle. And normally the graph y equals cos x, it completes a cycle in 360 degrees. Okay, so it will end at 360 degrees. From 0 degrees to 360 degrees. And then 360 degrees later, it will complete another cycle. Okay, and then 360 degrees before this, another cycle. But how we will determine what the cycle is by looking at the value in front of x. Okay, so in front of x, what do we have here? Well, it's just x plus p. Notice it's just a positive x. It's not 2x or half x. It's just x. So it means there's still an invisible 1 here, just like the original function. And so that means that it still completes a cycle in 360 degrees. So had there been 2 here, then how we would find this is we will take the mother graph, okay, y equals cos x, and we'll think about how long it takes for it to complete the cycle. And that's 360 degrees. And then you would simply divide by whatever number is here. And so this graph would complete the cycle in 180 degrees. But as you can see, the coefficient of x there was 1, so it still completes a cycle in 360 degrees. Moving on to the next question. Question 4.3 says, write down the values of B, Q, and P. Okay, so let's see. Starting with B, you see how the value here, right, it's going to change the period of the graph. So we could find out exactly what's put here because we know this is a sine graph. So originally its period is 360 degrees. Okay, a sine graph takes 360 degrees to complete a cycle, and then it will complete the same cycle again, the same pattern, 360 degrees later, and so on. So let's look at how long this takes to complete a cycle. I can see one single cycle here. So from 0 degrees all the way to what? So this is 0 degrees, and it goes all the way to 180 degrees. So this means that this graph is completing a cycle in 180 degrees. And so what does that mean about the value of B? From the previous question we just saw, the only way this could have been 180 degrees is if you said 360 degrees divided by 2, okay? Original period divided by whatever the coefficient is, and that will be 180 degrees. So that's how we know that the value of B is actually equal to 2. So we'll put that down. So B is simply equal to 2. And let's look for Q and P. Okay, so Q, it's just saying plus Q, meaning we took the sine graph and then we added to it, meaning you are either shifting this graph up or down. So look at the sine graph. Normally, this graph shouldn't be way up here. Okay, it should be here. So at 0 degrees, and then it goes up to 1, and then down to -1, and then back at 180 degrees, okay, for this case. But it went from this point, and then it's now up here. So how many units up was it shifted? You can just spot this by focusing on one point on the graph. For example, this was 0 degrees and 0, but now the starting point is at 0 degrees and 1. So it means that this graph was shifted 1 unit up. Okay, so we know that the value of Q, what was added to this graph to shift it up, was 1. So we'll just tell them this means that Q is equal to 1, and now we have to find the value of P. Okay, let's go ahead and find the value of P. So P is in the cos graph. Now notice what it says. It says cos and then x plus P. It's not like this case where you took the entire sine graph and then you added to it. We are adding directly to the x. When you are adding to x, it means that this graph is either being shifted to the left or the right. Okay, because adding or subtracting to an x value would shift it either to the left or the right. So let's focus on that cos graph. So here is our cos graph. And let's think about what the original cos graph looks like. So we know that the period was not changed because the coefficient of x is still 1. Okay, so let's just remember what the cos graph looks like. It goes up like that and then down and then back up. So we know that it should have a y value of 1 at 0 degrees normally. But where does it have a y value of 1 right now? It has a y value of 1 at -30 degrees. So it means that this graph, look at how it was supposed to look. If we moved it so that maximum of 1 is actually at 0 degrees, so like this, you see 0 degrees and 1, then it means that this is what the original graph would have looked like. As you can see, it's not completing a full cycle. However, if it was supposed to look like this, and this was supposed to be at 0 degrees, then it means that we took this graph and we actually shifted it 30 degrees to the left, and then it landed here. So this is what it was supposed to look like. It was shifted 30 degrees to the left. Okay, so what can we say about the value of P now? Let's speak about when you apply that left or right shift to your actual equation of that function. So you first look at it from the graph, interpret it. We know that the original graph was shifted 30 degrees to the left. Now, when you're applying this in the equation, you need to remember that if a graph was shifted to the left, you're just going to add to the x. Okay, so you say x plus whatever that left shift was. And if it was shifted to the right, you're going to subtract from the x. Okay, this applies to when you are substituting this into the equation of the function. So this means that we're going to have cos x, and then we're going to say plus 30 degrees, and that's going to shift it to the left. So it means that the value of P is actually positive 30 degrees. So that is our answer there. P is equal to 30 degrees, and that is it for question 4.3. Moving on to the next question. Question 4.4 says determine the value or values of x in the interval. So in this interval they have given us here, for which, and the first question is x multiplied by g of x is greater than or equal to 0. Okay, so the focus is on the graph of g. So you see that we're saying x multiplied by g of x. Remember that g of x stands for y. So what they're saying is when you take the x values, okay, and you multiply it by y values of g, they give you a value greater than or equal to 0. Let's think about the possibilities. So the only way that we can get a value greater than 0 is if this was positive and then you multiplied it by a positive, okay? And then you get a positive number, a number greater than 0. Another way you could get a value greater than 0 would be if this was negative and this was negative, and then we got a positive, okay? Remember that we can also get 0 if either one of them are equal to 0, and then it will be 0. So we'll keep that in mind. So I'm going to go ahead and pin this, and then we're going to see where this exists in our graph. Okay, so what we're looking for is, can we see a place where the x values are positive, and then at the same time, the y values of g are also positive? Okay, so we're looking for positive x values. Here's our x-axis. Where do we have positive x values? We have positive x values all through here. So you're only going to look here. So it's either in the first or the fourth quadrant. Let's just see based on this. We know that the values of y for the graph of g, they should also be positive. Remember that with graphs, okay, so thinking about whether y values are positive or negative, let's speak about the graph of g. If we said that g of x was greater than 0, right? This means that the y values, we're looking for where the y values of g are positive. Think about it like this. You have an x-axis, you have a y-axis. The only place you will find positive y values would be over here, above the x-axis. Okay, that's where you have positive y values. And where you have negative y values, it will be below the x-axis. So we will only look for, if we're looking for positive values, positive y values, we're going to look for parts of the graph that lie above the x-axis. Okay, so let's go ahead and see. Do we have anything like that? So positive x values, positive y values. So you're only going to look above the x-axis, meaning we're going to just focus on the graph of g, and we are going to highlight everything that lies in the first quadrant. Okay, positive x values and positive y values of g. Okay, so the positive y values can only be here. So the graph of g is this graph, and you can see that the only parts of the graph that exist here are literally this. That's it. Okay, and now you just have to tell them the values of x for which this little piece exists. So that this piece, if you line it down to the x-axis, you can see that all of these points that are on this graph, right, their x values are, it's where we have x is equal to 0 degrees, and then values that are greater than 0, but then less than or equal to 60 degrees. So here's the thing about it. Remember that they can be greater or equal to 0. If you look at this point 0 degrees, the x value is equal to 0. Okay, x equals 0 degrees. So if you take 0 and you multiply it by the y value of g, which is somewhere here, okay, maybe it's like, root 3 over 2. And if you multiply them, they will still give you 0, so it meets the requirement. So we're going to take 0 degrees, and then we're going to take all the way to 60 degrees. And the reason we're including 60 degrees is because, do you see there's an x-intercept here? The graph is intersecting the x-axis, meaning its y value is equal to 0. Okay, so it's clearly values that are greater than or equal to 0 degrees, but less than or equal to 60 degrees. And that would be our answer. So simply tell them, okay, we found our first solution. We'll check the second one as well. It's where x is greater than or equal to 0 degrees, but less than or equal to 60 degrees. In interval notation, you can also write this as x is an element of, and we're going from 0 degrees to 60 degrees. But remember, x is greater than or equal to, and also equal to 60 degrees. So you're going to use square brackets. And there we go. Okay, now let's go ahead and look for the second requirement. We found the first one. We found that we actually could find positive x values and positive y values of g. That works out. Now let's go ahead and look for the second case. Can we see where we have negative x values and then negative y values of g? Okay, so negative x values is all through here. Negative y values of g, okay, they're negative, so it's below the x-axis. Unfortunately, do you see how the graph of g doesn't go anywhere here? So there's no solution for this side because there's no graph that exists here. And then that means that this is our only solution, and that is it for that question. Moving on to the next question. Question 4.4.2 says we need to determine the values of x for which f of x minus sine 30 degrees, which is a half, and then is equal to g of x plus 1. Okay, let's just simplify this further. So f of x minus sine 30 degrees is a half, and then is equal to g of x plus 1. We can just, because there's no use of really leaving these together. Imagine having to subtract 1 from f, and then you must shift it a half units down, and then shift that 1 unit up. So let's just go ahead and bring g of x over here. So we have f of x minus g of x, so it becomes negative, is equal to, and this is 1, and when a half goes over, it becomes plus a half, which is 3 over 2, or we could also say 1.5. Okay, so where can we see that we say f of x minus g of x, and it gives us 1.5? So what that means is, and let me just pin this. So what that means is we'll look at the graph of f and then minus the graph of g. So the y values of f minus the y values of g. Where do we have a y value of f, and then you take that and you subtract it by a y value of g for the exact same x value, and then it gives you 1.5 or 3 over 2. Okay, you see, with your ruler, you can actually just try to find where this could possibly be. Start from the graph of f, okay, because you know that you're taking a y value on f minus a y value of g. And you're just going to measure what 1.5 looks like. So you can measure that looking at this. So you see from 0 to 1.5, it's about that high. So you'll do that with your ruler. Just measure how many centimeters is there, and then start scanning through and just seeing the possible places where you could find solutions. So if I look through here, you see that, yeah, that's never going to happen, okay? I could never take the graph of f and then subtract the graph of g, and it actually gives me this height, this exact height. And we keep moving and we keep moving, just keep moving, focusing on the graph of f. So I want the top part to be on the graph of f. And when I keep doing that, you see the height does not match here. Okay, keep following it. The height still doesn't match yet until over here. Okay, so there's probably a solution here. Yeah, I don't always like these questions because sometimes the solutions are ones that have decimals. And for you to find that, you need to use general solution. So I may not even take that answer, but let's just keep moving. Do we see any other solution? So if we keep moving, as you can see, this height is too small. Okay, if you took the y value of f and you said minus whatever this y value of g is, it's going to be a value greater than 1.5. So we can't take that. So I'll keep moving along the graph of f, okay, keeping that on the top part. And I just want to see where it has this height, approximately this height. Okay, so probably at 90 degrees. And okay, let's just go ahead and check the y values here. So you see at 90 degrees, okay, the graph of f has a y value of 1. You can double check that on your calculator. So on our calculator, we can simply just say, take the graph of f, which we know is sine bx. So this is sine 2x. So we're just going to say, in place of x, we're substituting 90 degrees. I want to see if it actually does have a y value of 1. So 90 and then plus q, which was 1. So there, it really does have a y value of 1. And then here, it's saying that the graph of g has a y value of negative a half. I know that 1 minus negative a half really is 1.5. So you can also just check with the graph of g, cos x plus 30 degrees. So we'll say cos 90, because our x value is 90 degrees, plus 30 degrees is equal to negative 0.5. So yes, we have a solution over here. We can keep moving and just see. So I'll copy that. And let's see, do we have any other solution? Okay. When we keep moving along this line, you can see that, unfortunately, this height that we are working with is too big. It's not working all through here. Still not working. Still not working. And it seems to work somewhere here. So it may work somewhere here as well. Okay, so seems like we have 3 solutions. But this is like in the middle. I have no idea what this is. I doubt. Okay, you can test it out just to check if it really does. If you try sine with 60 degrees, okay, the sine graph, and in place of x, substitute 160 degrees. Okay, so if we do that, and then we know we have plus 1, yeah, it's probably not there. Maybe it is, but then you see, if you take this, and then you say minus the graph of g, okay, which is cos, and in place of x, I say 160, and then plus 30 degrees. Yeah, I get 1.3, not 1.5. So it's probably something with a decimal. That's the reason why I say sometimes these questions, I don't really like this particular question because there's usually more solutions and then it's not worth the mark allocation. So what I think is they want you to take the obvious one, which is the 90 degrees. So forget the ones that it probably happens at an x value with a decimal and just take this one that is very clear at x equals 90 degrees. Okay, so our answer will just say it means that this happens at x equals 90 degrees. Okay, the y value of f minus the y value of g over there actually gives us 1.5. And that is our answer. Moving on to the next question. Question 4.5 says, given h of x is equal to g of x plus k, determine the value or values of k in the interval, okay, in the same interval, where h of x is also equal to sine negative x. Okay, so we have the graph of h, right? And h of x, they're saying it's equal to sine negative x. But h of x is equal to g of x plus k. So they're saying these two are exactly the same, right? But we get h of x by saying g of x. And then we add something to this x value. So what exactly should the value of k be for these two equations to be exactly the same? Okay, so all we're trying to do is we're trying to get this equation to look like this one. Let's just fill in what this will be. And I think we should just look at them side by side first. So I'm going to work more with this one because I think it'll be easier to get this to look like this one. So let's just look at them side by side. I will put this one, I'll leave this one here. Let's put this one on this side. Okay, so this is h of x is equal to, and we have g of x plus k. Let's just expand that. G of x plus k, our graph of g was the cos graph, remember? That is cos x plus 30 degrees, right? So we have, this is cos x plus 30 degrees, but you see that they have added a k. So you can't say plus k and then plus 30 degrees, no problem. And then we need to find out how these two can end up being the same thing. So what is the value of k, or values of k, for which these two equations will end up being the same, since they are both the equation of h? Okay, so this is a sine graph. This is a cos graph. How do we get sine to say cos? We can do that using cofunctions. So this is, we have sine negative x. Whenever your angle is negative, you simply add 360 degrees to it. So what you would have is sine 360 degrees minus x. But we know from the cos diagram, okay, our reduction diagram, we know that 360 degrees minus theta or minus x, right? That is in cos's quadrant. Okay, that's where we have this reduction. So sine is negative in this quadrant, meaning this would simply become negative sine x. Okay, so how do we get negative sine x to look like that? Well, we needed to say cos first. We can do that using cofunctions. And honestly, I've seen this question before. I think it might have been in a grade 12 paper. I'm not sure. So look at what we can do here. You see that with our cofunctions, there's one cofunction that specifically says cos x plus 90 degrees, or 90 degrees plus x, right? This is equal to negative sine x. It's the only one that gives you a negative, okay? So it means that we can actually change this, because I needed to say cos. We can change this negative sine x using cofunctions, and we can change it to cos 90 degrees plus x. Okay, so now they both say cos. Now we just have to think about it like this. For which values of k will this function look exactly the same as this function? What should k be for them to look identical? Okay, let's just put them in the same order. This one has 90 degrees plus k, but this one starts with x. So I'm going to rewrite this as cos, and I have x first, and then plus 90 degrees. So now can you see what exactly should the value of k be for these two equations to be exactly the same? You can see that k should simply be what plus 30 degrees gives you 90 degrees? 60 degrees plus 30 degrees gives you 90 degrees. So for them to be equal, k must simply just be equal to 60 degrees. Okay, if k is equal to 60 degrees, it's also going to say x plus 90 degrees because you put 60 there. Okay, and that is our answer. And that is it for question 4. Question 5.1 says, in the diagram below, triangle ABC is sketched. And they tell us that angle B is an acute angle. Use the sketch provided on diagram sheet 2 to prove that sine B over B equals sine C over C. Okay, so we are proving this sine rule using an acute angle triangle. Grade 11s, remember that they can also ask you to prove this using an obtuse angle triangle. So you need to know how to prove both cases. Okay, so with an acute or obtuse, it's still the same idea. We have this triangle and we're trying to form sine angle B and sine angle C. We can see that angle B is over here, but for you to form sine angle B, right, remember that sine from SOHCAHTOA, and I'll just put it down already, SOHCAHTOA, that sine is opposite over hypotenuse. And so you can only do that with a hypotenuse. And the only type of triangle that has a hypotenuse is a right angled triangle. Right now, we don't have a right angled triangle, so we're going to actually create one by drawing a height. Okay, so let's just list some things that we need to do. First, let us go ahead and put down this height. So the height of this triangle is from the highest point of the triangle down to the base, and it's going to be perpendicular to that base. Now, I'll go ahead and call it H, and let's name these other sides. So the correct way to name these sides is like this. For example, if I want to name the side AB, I don't want to keep calling it AB, and I can see that they clearly did not call it AB because we don't have anything like that. So it means that they named the sides according to whichever angle was opposite it. Okay, so we have angle C here, or point capital letter C. So it means that the side opposite it is small letter C. And then this one would be small letter B. And this one is small letter A. Okay, so now that we have done that, we can start proving. Okay, so the only construction that we have made is we have drawn a height. So we just tell them, draw a perpendicular height from A, okay, to this base BC. So perpendicular to BC. Okay, so now to prove this theorem, remember we have sine B and sine C, sine angle B and angle C. So how do we form sine of angle B if angle B is over here? Sine is opposite over hypotenuse. So it means that we're clearly going to use, because we need a hypotenuse, we need a right angle triangle. We're clearly going to use this triangle that we have formed over here. So opposite over hypotenuse would be this height over the hypotenuse of C. Okay, so we'll go ahead and write that down. We know that sine angle B equals H over that value C. Okay, so that's sine angle B. And then we can also just go ahead and form sine angle C. So here's angle C over here. If we take sine, it's opposite over hypotenuse. So opposite angle C in this right angle triangle, because we are using trig function, so it must be a right angle triangle. So that is H over this hypotenuse of B. So H over B. So let's go ahead and write that down. That is sine angle C equals H over B. Okay, what do you notice about these two equations? Because we've successfully created sine angle B is sine angle C, just like in the proof. Okay, in what we have to prove. Do you notice how they both have H? So if we can make H the subject, which is the only thing that is not written here, then it means that our formula, what we have to prove, it's going to include sine angle B and C and sine angle C and B, which is what we're trying to do. So in both equations, we're going to make H the subject. So to make H the subject here, you need to get rid of the C. The C is being divided. So we're saying divided by C, meaning to get rid of it, you multiply by C. For what you do on one side, you must do on the other side. So finally, it would mean that H is alone, and H is simply equal to C sine angle B. Okay, do the same thing over here. You need to get rid of this B, so multiply both hand sides of the equation by B, and so H is equal to B sine angle C. But we know that H and H are the exact same thing, so we're just going to equate them. Okay, so we'll say we know that H is the same thing as H. So we equate the equation, so we have C sine angle B is equal to B sine angle C. Okay, we're almost done. Now do you see that in what we have to prove, side B and side C, they're both in the denominator. Okay, so we need them to go to the bottom. How do we do that? Right now C is multiplying to sine angle B. To get it to go to the denominator, you would divide by C. And what you do on one side, you must do on the other side. We also need B to come to the denominator as it is in the formula. So also divide by B. So you can see them as they are multiplying, but yes, we are actually dividing by B and C at the same time. Okay, and so that would mean, what do we have left here? Well, C and C are common, so they will cancel. And so you're left with sine angle B over B. And then on this side, this is equal to, and we have here what happens. You see how we have B and B, they would cancel. So this is sine angle C over C. And there we go, we have proven this theorem. Okay, so moving on to the next question. Question 5.2 says, in the diagram below, AB is a vertical pole, and then the angle of elevation from C to the top of the pole is alpha. The angle of elevation from M to the top of the pole is theta, and then CM is x meters. I've also seen this one before. Okay, so I found out that this one is actually, it was also in 2021's September exam, okay, specifically from Gauteng. So I'm sure you can find it there as well. So it was question 7.2. You can also find a very similar question. And they also asked this question immediately after asking you to prove this theorem. So you should probably go out and check out that one, because with that one, the theorem they ask you to prove is specifically for an obtuse angle triangle. Okay, so you can see the difference between how to prove those two. Okay, so looking at this question, they want us to show that the height of the pole AB, same thing, they also asked for the height of the pole, that is given by this equation. Okay, now just use this as a guide. Don't overthink this part and try to force it to be this. Your mindset should still be, they asked for AB, so I'm going to construct a way to find AB. I'm just going to keep looking at this to make sure that I am on the right path to find AB. Okay, so let's focus on AB. If you were given AB here, how would you find it initially? Okay, so I would want to use this smaller triangle, because if I try to use the bigger triangle, the thing about it is I don't know what AC is, and I also don't really know what CB is because MB is still missing. So I would rather start here. And so to find AB, we can go ahead and start by using this, and we can say we are looking for the opposite side. And you see how this triangle, because it has alpha over here, we have another triangle in here, an obtuse triangle. And look at the amount of things you have here. You've got alpha, you've got x, you have this angle, since this is theta, this is 180 degrees minus theta. We've got stuff that we can actually work with here, meaning we can also find this angle. So I'm going to go ahead and use AM. So this is going to be the opposite side, and I'm also using the hypotenuse. So clearly we're going to use the ratio for sine. Okay, so sine theta. We'll start off there and say that sine theta is equal to the opposite side, which is AB, over the hypotenuse, which is AM. Okay, the whole goal is to get AB. So I'm going to make AB the subject so I can see what I need to search for to find this. Okay, so to make AB the subject, you see that you need to multiply both hand sides by AM to remove it from the denominator. So this means that AB is finally equal to, for now, it's just going to be equal to AM sine theta. Okay, so what's our next goal now to find AB? Well, you can see that AM is missing because this is sine theta. Okay, it's in terms of what we need it to be in terms of. Sine theta is included here. So the next goal is find AM. Okay, so focus on AM. How would we find this? Clearly, because we're finding this diagonal line, we need to use this obtuse triangle. Okay, so we need to find AM. We have the angle opposite AM. And then if we also have one complete pair, for example, I don't actually want to find AC because I'm not really seeing a very clear way of finding it. However, they did give us CM. So we could use CM and then the angle opposite it. And so we'll be using the sine rule, which makes a lot of sense, seeing that we just proved the sine rule. Okay, so the next goal is we need to find this angle. Okay, so to find this angle, just find this one. Now you know that the angles in a triangle add up to 180 degrees. So this angle, very simple, AMC is 180 degrees minus theta because it lies on a straight line and that is theta. So let's just state that AMC is equal to 180 degrees minus theta. Now that we have that, we can find this angle. So that is the angle CAM, CAM. Okay, so to find CAM, we're going to say this is 180 degrees minus all the angles we have here. So we have alpha 180 degrees minus theta, and then would find that. So if you say minus 180 degrees minus theta, okay, and then minus alpha. Okay, because I'm seeing this as one single angle, and then I'm saying minus alpha as well. Okay, it's not part of this. So this is 180 degrees minus 180 degrees, and then that becomes a plus theta, and then this is still minus alpha. Okay, so you can see from this that 180 degrees would just cancel, and all you'd be left with is theta minus alpha, which makes sense. See how they have that there? Okay, so you don't force it here. You think about how to find AB, and then from there it will start leading you. You'll see, okay, to find this, I must find that. So we know CAM or angle CAM is theta minus alpha. Okay, I'll just fill that in so I don't forget. This is theta minus alpha. And now we can go ahead and use the sine rule. And remember, the whole point is to find AM. Okay, so we're going to use the sine rule. We're trying to find a side, so just make AM the subject. So we're saying this side AM over sine of the angle, it is opposite. So AM, the angle opposite, it is alpha. So over sine alpha is equal to, and then you said side over sine angle, so you need to say side over sine angle as well. So the next side is CM over sine theta minus alpha. So this is going to be CM, which we see that is X. Okay, so I'll just say X over, and we have sine theta minus alpha. And all we are trying to do is find AM. Okay, so to make AM the subject, you see that sine alpha needs to go. So if you multiply both hand sides of this equation by sine alpha, you're going to get AM is equal to, and sine alpha multiplies and multiplies here. So it's going to be in the numerator here. So it's going to be X sine alpha all over sine theta minus alpha. Okay, so that is AM. And now that we have AM, we can find AB. So we'll take this equation that we already had. We knew that AB was equal to AM multiplied by sine theta. And we're going to substitute AM in here. So it means that AB is simply equal to, and this is X sine alpha over sine theta minus alpha, and then multiply by sine theta. And you're just simplifying now. So finally, it means that AB is equal to X sine alpha and then sine theta all over sine theta minus alpha. And that is our answer. And just verify that they are the same. X sine alpha, sine theta, there we go, over sine theta minus alpha. And that is our answer. And that is it for question 5. Okay, so that is the last question for this paper. I hope you guys enjoyed it. Please make sure to leave a like, comment, and share. It really helps with the growth of the channel. And I hope to see you guys in the future videos.